Okay.
All
Um,
right, Chris has got it.
yeah, I'm going to be sharing with you guys some introductory Python stuff. Now, I'm not so the way that these slides were designed, I kind of focused more on the object oriented part and some data structures type stuff. So feel free to stop me if you've seen it already. Let me see here. Oh shoot, it's not going to let me share my screen. Hang on 1 second. 1 second, guys. Okay, here it goes. Alrighty, Python introduction slash review. More specifically, we're going to talk about data structures and some object-oriented programming in Python. Now, as far as I'm aware, you guys have touched on a lot of the basic control flow of Python, and obviously, if you've used Python before, a lot of this will be very familiar to you. But let's start with this. What are objects? Objects in object-oriented programming is just a way to group data. We could use a person object, for example, which contains an age, a name, and an address as instance variables. In the case of Python, Python treats everything like objects, things like arrays and dictionaries and all that kind of thing. Everything in Python is an object. Functions are even considered objects. So you could assign a variable to a function, and you could pass it around, and then you could call it later, which is interesting and makes for some fun control flow. You can see over there on the right side, I have an example of passing in a function, and then you can run it later. Another thing about Python in particular is it passes variables by reference for the most part. And basically what that means is whatever you write, when you write y equals 1, 2, whatever, y is simply representing where that number is in memory, but it's not storing the value itself. So in the example with the array, I assign x to an empty array, I assign y to x, so now x and y are both pointing at the same object, right? And then I make a change to the original array, and that change is reflected when you look at both x and y. Kind of interesting stuff. Also, there are such things as mutable and immutable types in Python. Mutable means the object can be modified, and immutable means the object cannot be modified. Pretty simple. All objects are immutable, such as integers, floats, strings, booleans. Sorry, not all objects, but those 4 objects are immutable. When you use operations such as plus equals, so that's basically saying y equals y plus whatever, it creates a new object and assigns it to y. So if you say x equals 4 and then y equals x, technically at that point they're both pointing at the same object. But if you do any arithmetic changes to x, it will create a new object and reassign x. So y would still be 4 in that case. Thinking about it that way kind of will help you understand why some weird stuff happens with passing objects around. But for very basic types like integers, floats, strings, and booleans, nothing to worry about. Okay, so let's talk about a few data structures then, starting with ordered data structures. You guys should be familiar with arrays to some extent. In Python, it refers to them as a list. You can read, modify, or remove any of those elements. In Python, arrays can be mixed types. So what that means is you could have an array that has a 2 next to a string, next to a custom object that you've created yourself, whatever you really want. And it uses this square bracket notation. So are you guys familiar with indexing? Starting from zero indexing and all that kind of thing. I have a little example here on the right where I created an array. right? I add two elements to it, and an empty dictionary, which is just another type of object. So now we have an array with 4 elements in it. Um, and then, I can print it out there and you can see the result. And then I can reference array at 0 to get the first element of that array, right? So index 0 is the first element, and then index 3, in this case, in a 4 size array, would be the last element. Structures that can be implemented with arrays. I'm going to breeze over this, but this is probably also pretty important to think about. There are multiple ways that you can structure data in your application. Just think of the ways that you would need to put data into a structure and pull it out. A stack is the first kind of structure. That's treating an array with a last in, first out mentality, right? The last object that you put in will be the first object that you pull out when you look at the array. Like a stack of papers on the desk, right? The paper at the bottom is the least important thing, and you're not going to be able to get it without removing everything else on top first. If you have some kind of structure in your application and that's the way that it works, then that's probably how you want to treat it. Queue is another one. First in, first out, like a line at a store checkout or a line at anywhere. You enter at the back, right? So then you would be the last index, but we don't care about who's in the back. We care about who's in the front, who is the next person to come forward, right? So once an object goes in there, it doesn't get revealed until later. And then multi-dimensional arrays are something important to think about. You can make and visualize things like matrices, which are 2 by 2 squares of numbers or whatever. But all it is an array that contains multiple arrays, basically. And that's important when you're trying to represent something like XY coordinates on some kind of field. None of these, besides multidimensional arrays, stack and queue, you can't directly reference in Python. They don't have a specific data structure for it, but you can implement a stack and a queue with an array. Okay, and we'll briefly touch on tuples because it might be important in your apps too. A tuple is an immutable list of elements. You can't change the size. It's like a list or an array, but you can't change the size of it, and you can't write any new objects or replace any existing objects. It acts as a primitive in that kind of way. It's really good for transporting pieces of data, knowing full well that it's not going to get changed on the way. And the way that you use it is you define it with parentheses notation instead of square brackets. And you see I have a little example there. If you try to do indexing and then set it to something else, that'll fail with a type error. It'll throw an error. I have a Python notebook here that kind of goes through a lot of this stuff, and I'm hoping to get this to you guys, but I can show you a few quick things here. Can you guys see this okay? Anybody? So this is an example of the references again. ID basically pulls out the memory address of an object, right? So this X is just pointing at the array somewhere in memory. And ID tells you where that is. And so you can see when I set Y to X, the IDs that both of these are pointing at are exactly the same, right? That returns true. And then you can print both arrays, see what they print out. I can append something to the X array, and since they're both referencing the same array, the change is reflected in both. And then going through ordered data structures again, this is just what a multi-dimensional array looks like here. This is a basic array. This is my implementation of a stack, of a queue. You could use these implementations if you need them. But basically how the stack works is I have a push function and I have a pop function. That lets you add elements on top of the stack, and then the pop element lets you remove elements from that stack. And something similar to the queue, except it's a queue function and a dequeue function, which I found kind of funny. And then here's the tuples again. And yeah, that throws an error if I try to set anything to it. So, okay. With that, I have a quick question for you guys, and I'd love if you could toss your answer into chat. Which of these code blocks will run without error? Can I see the chat right now, actually? No, I don't know how to see the chat.
So go
me.
up top where
Oh,
there's the ... menu, and you can pull down chat.
Got it. Hopefully I'm not covering that. Yeah, that's totally right. As I showed multiple times, tuples are immutable. Good thing. Man, that was a lame example then. You guys got that immediately. All right. Yeah, this first line of code there is something known as destructuring, which separates the tuple into two variables. It's just a fun little thing. If you write x comma y equals a tuple of two elements, it'll set x to 3 and it'll set y to 2. So that was a fun little thing that I put in there.
Yeah, sometimes
Yeah, sorry, go.
Sometimes you'll see that called unpacking. So you're unpacking the tuple into x and y.
Is it called? It might be called destructuring in JavaScript or something.
I'm not sure what it's actually called, but I've heard it both ways. You know, it's like a decorator, and there's lots of names for things. So
anyway, it helps shorten your code. It helps make it a little bit more readable. It helps you quickly split up these tuples without having to use any of the weird indexing or anything like that. Indexing is not weird. I just said that. All right, unordered data structures now. These are a little bit different, obviously, from arrays because they don't have an implicit order to them. And I'll show you what that means. But first, let's touch on hashing for a second. Objects in Python tend to implement what are known as hash codes. Some objects may not implement hash codes, but then you can't use those in unordered data structures. But here are some basic rules about a hash code, right? It's an integer, first of all. If two objects are considered equal, their hash codes must be the same, right? It should try to minimize duplicate output values. So sometimes you'll have an object that's unequal to another object and their hash codes are the same. That's okay. That's called a collision. You want to avoid making collisions. But you wouldn't want it to go the other way, where two objects are the same, but their hash codes are different. That would be wrong, and that would defeat the purpose. It also should be very fast to compute. There are lots of hashing algorithms when it comes to making a string into a unique hash that doesn't collide with other strings. There's a whole math to it, but for now we'll stay basic with it. The hash code basically represents the index of the object in memory. So if I have a string like cat and its hash code is 434, you can picture an array that's 10,000 elements in length, and if I put in the string cat, it'll go to index 434, right? And basically that means that when you're checking your structure, if cat has been put into that structure, it's instant because it computes the hash code really fast, and then it knows immediately where to go in memory to look for it. You don't need to search through the array to find such a thing. And that's what makes hash tables and sets very, very fast. So now we can, I still had more about hash codes. Great. Yeah, that's a quick example there. In order to find apple. Okay, that's basically what I just described, but with the whole cat thing. If you assume apple is 1, orange hashes to 5, pear hashes to 8, then you can have an array of many, many strings, and you can tell if apple is present just by looking at the starting memory index of the whole structure, and then that hash code. So here are the data structures. We have what are known as a set and a dictionary. Both of them use this curly bracket notation. You could also, I have in a little comment there, you could say data equals set, and then you can pass in a list, a typical list, and it'll convert it to a set. And basically what that lets you do is it lets you run things like for in data. What that does is it checks if the number 4 is in the set. And it does that instantly because it's very fast about that. Sets are also really useful if you want no duplicate values in a list. If you have a list and you want to remove all duplicates, just convert it to a set. Everything that hashes to be the same value will eradicate each other, and you'll be left with a lot of unequal values. Now, that may not be totally useful. What if you need a value paired with those structures? And that's what a hash table is, right? In Python, they're known as dictionaries. And basically what you can do is you can reference an object at a point in this dictionary. So basically in a set, if I put in the string cat, right, that references to a single point in memory. But instead of just putting an indicator to say, yes, it's in the array or no, it's not, you could put a totally different value there. You could put a new object, you could put you know, something else. I put a really confusing example there, and I don't know why I did that, but you have the integer 1 resolves to the string 1, the integer 2 resolves to the string 2, and then I just added a little indexing thing there that says the string 3 resolves to the integer 3. And then you can see what that hash table looks like below. So you can check if the key, right, is present in the hash table, and then that key resolves to a value. And just like before, it's instant. It's known as a constant time lookup. So if you have a hash table with lots and lots of key value pairs and you need to reference one key, it looks it up instantly. All right, what do you guys think happens when we run the above code? Nice. Nice, guys. Yeah, no, it's not ordered. Sets are not subscriptable. You can't look at what element is at 2. So it'll throw a type error. Yeah, very good. Okay. And maybe I can pop back here for a second and see if there's anything else interesting. So in Python, you can use the hash function in order to get the exact hash code of any object, right? So the hash of the string hello is this strange large negative value. And again, there's a lot of math that goes into it, but if you're having trouble figuring out a hash code for your object, think about if you can make the elements of an object into a string that's unique, and then you can use Python's built-in hashing function to convert that string into a hash code which is less likely to collide with other things. That's a trick that I always use because I'm not good at writing hash functions. I'm not a mathematician. Why would I? And then the hash of the integer 20 actually resolves straight to 20, because if you have another integer that's 20, they're equal. If you have a different integer, they're not equal. I haven't tested it with floats, actually.
I'll inject a brief aside. There's a whole math and theory about generating hash codes that's pretty cool to make certain guarantees about low collision rates, even if you don't know what data might end up being put into your structure. But most of the time, that level of theory isn't necessary to write a useful hash function.
Yeah.
But there's stuff called universal hash codes that are really cool, and it's not obvious that it's even possible, but there's really cool guarantees you can make about hash codes having an extremely low collision rate and still be very simple to compute. But
yeah,
but don't worry about it.
It's pretty cool. Anyway, if you guys just saw that while Rob was talking, I had a 0.1 and it resolves into a really long hash code, because obviously a hash code has to be an integer. It can't be a floating point number. Anyway, that's kind of funny. Here, I wrote a class person here because I wanted to demonstrate using my own custom hash function, right? When you're building a class or an object and you want to use it as a key in a hash table, or if you want to use it as a value in a set, what you're going to need to do is implement both a hash function and an EQ function, right? And that the EQ function takes in another object, and then you tell it if those two objects are equal. And the hash function just simply returns a hash of the person. So in this case, I'm only using the string name in order to resolve the hash function, which means what I'm basically saying is if these two people have the same name, it doesn't matter if their age is different, they're the same person, right? That's just the way that I've implemented this one. Might not be ideal in some cases, but maybe you only want to compare equality based on a few values. And then I can see here that the hash code of them both is the same. Yeah, young Bob and old Bob both have the same hash table or hash code, and then Joe does not have the same hash code as either young Bob or old Bob, which makes sense. We can't add both old Bob and young Bob to a set now because they both evaluate to the same hash function. So if I make a list with young Bob and old Bob, and then make a set out of that list, what you'll notice is, so first of all, this is the list, right? I printed out the list, and then this is the set made out of that list. There goes our duplicate value. Yeah, and then I have a little bit more here about hash tables and sets. You guys can feel free to look at this later, but I'm gonna head back to the slides here. Okay, object-oriented programming now, OOP, as it's most commonly called. Let's take a step back. We'll talk about classes and objects here for a second. So a class is essentially a type, just like an integer is a type, a string is a type, an array is a type. A class is letting you define a new type, and it acts as a template for the objects that you create of that type. It lets you define all the instance variables and the member functions that an object of that type has access to. An instance variable is something that is a variable that's a part of the object, such as person .name, right? And a member function is something like in that example there. Get name and set name are both member functions that let you modify something about the object, learn something about the object. Yeah. And then in Python, when you're defining all of these functions under a class, you need to pass in self. And what self is a variable or a pointer that refers to the object itself, right? So if I call self.name inside one of these functions, I'm referring to the object's name instance variable. And I can set that and manipulate that however I want. So objects then are individual instances of a class. They are of the, so if I made, in the example here, making a person Chris, like me, the type of that is the class. And then the Chris.getName function returns Chris. Now, if I set my name to Michael, which would be crazy because my name's Chris, and then get that name, the name returns Michael. Yeah. And most commonly, you'll have getters and setters for a lot of your instance variables. I could technically call Chris.name, right, with no parentheses or anything in order to get the name. But that's not really a good way to go about it. I always recommend using getters and setters because in these getter and setter functions, you can kind of control how the data is accessed and how the instance variables are exposed, right? If you call Chris.name, but I don't want you to be able to modify the name, then you can go ahead and modify it. You can do whatever you want. But if I control it with a getter and I don't have a setter, then there's no function available for you to change the name. So I always recommend using getter and setter functions as opposed to directly modifying the instance variables. It'll make your life a lot easier. Okay, yeah, what'll happen when we run the above code? I think you guys got the hang of this, but what'll happen when I run the above code? Anybody in the chat? Isaac got it. This actually, this exceeds the max recursion depth. This is a problem because get name right here calls itself. It doesn't actually return any name. Yeah. So the correct way to write the code would be get name self, and then I would return self.name. But since I'm returning the function again, it just calls itself forever and it doesn't ever find the instance variable. Anyway, I thought that was, you guys like that example? I thought that was quite clever. All right. All right, and now if sets do not allow duplicates, why is person set length 3? We talked about this earlier a little bit, but maybe you guys can remember why there would be duplicates in here. So basically what's going on here is there is no equals or hash function, right? And let me see here. Yeah, they do all have different addresses. They have different hashes. So here's what happens when you don't implement an equals or a hash function in your object. What it does is that object then references the direct memory address that it's sitting at. What that means is every time you create a new object, no matter what the values are, they will always be at different memory addresses. So every single object, every single person object will always be different, and you won't have any proper hashing used. Yeah, so like I said, custom classes by default use the ID command to generate a hash code. ID returns the memory address of an object. So no objects are ever at the same memory address at the same time, and they'll never be equal. What makes two-person classes equal? Well, in this case, the name function makes them equal. So we can define that EQ function, and notice that I'm using the getter in here, right? I'm using self.getName instead of just referencing self.name. Again, I always try to use getters and setters. I recommend you guys do that kind of thing too. But this won't work for hashing just yet. Not only do you need to define equality of functions, then you also need to define the hash code. If you define equality without a hash code, and then you try to add it to a set, none of it will work because Python knows that some of those objects are equal, but it doesn't know which ones based on the hash code. So it won't let you add that kind of thing to a set. So like I said here, in my case, I always just use the string hash function because I don't know the math behind it. So I hash self.name, and that's the hash code I get. Our code works as expected now, and we get a length of 2. All right. So let's talk about inheritance. Inheritance is interesting. Assume we have a pet class. It has instance variables such as a name, an age, and a more. Okay, and more, that's what I wrote. If our pet is a cat, we want access to a meow function, for example. That function doesn't make much sense if the pet is a snake, because snakes don't meow. So we use inheritance. We can create a cat class that extends from pet and a snake class that also extends from pet. What that'll let us do is it'll let us define custom functions and custom instance variables. These classes both share all the functions and variables that a pet would normally have, but it would allow that new class to add new functionality based on the type. So our pet class could just have name and age, and then your snake class could implement everything else. In Python, this is achieved during the construction of the class. So notice the notation over here. I define a pet class, which looks pretty standard. It looks kind of like the person classes we were using before. But following that, we have a cat class. And in parentheses, after I've defined class cat, I put pet. And what that tells Python is it says, okay, use everything from the pet class and inherit off of that, right? Now we define this new meow function that prints, something. Self.name says meow. But the interesting thing there is in class cat, obviously we haven't defined any self.name. We haven't defined an initializer. We haven't defined anything like that. All meow does is it adds a function which still references the same object, right? So since it extends off of pet, we know it has a self.name and we know it has a self.age. And we can reference that there in the print. Oh, and I broke my own rule. I wrote self.name instead of self.getName. That's a bad example. Don't look at that. Yeah. So what if we want additional variables initialized for the snake class? We didn't have an init function in the cat class, but in the snake class, we want to know what color he is, right? We do the same thing. We pull in the pet, but now we can do something else interesting. We can call, inside this new initialization function, we can call the pet initializer within snake. And that's just done by doing pet.init, and then you pass the object, you pass the name, and you pass the age. But then you can add your own instance variables, such as a color. So classes of type pet will have a name and an age, and now classes of type snake will have a name, an age, and a color. If you define an init function, it requires that you call the parent's initialization function too. If you don't call the pet's initialization function, it won't have a name or an age set to the object, and it'll throw an error because it's not being properly constructed. Yeah, and then I add the getters and setters for that, and now you can get the color of your snake. So when do you use inheritance? Inheritance becomes necessary when there is a relationship, right? If a snake is a pet, then it makes sense that a snake extends off of pet. And that will extend to other things as you're writing your programs, your mods. For example, maybe and you guys can, Joel and you guys can jump in here, but maybe a person extends off of a entity, right? And a zombie extends off of an entity. Similar to that may be a place to use inheritance, right? It's got some specific things about the object that maybe you want to inherit off of. It's also possible that you won't need inheritance, right? You could have an entity class and just have a type instance variable on it. And what that means is I could have an entity class and say that it's a type person. Maybe there's not enough difference between a person and a zombie when it comes to running the game that you would even want to do inheritance and all that. Sometimes it can get a little bit messy. Okay, with all that said, let's take a step back, talk about enums for a second. Enums are used a lot in the Z game. And this is how they work in Python. An enumeration is a set of names bound to unique common values. And the way it works in Python is you import enum, and then you basically create a class that extends off of enum, and then you set those enums, right? That way, you can now use color.red to refer to the red color, even though in the technical back end of it, maybe the red color just refers to the integer 1. Maybe the green color refers to the integer 4 for whatever reason. But it lets you hide away some of that complexity and require and kind of require that you're passing an object of type color. So you don't want somebody to pass in the integer 3 because maybe you don't have a color for that yet. But it lets you outline the types, and it lets you kind of organize and hide complexity of your code. It exposes them as constant values. You know, you can use them anywhere. You can set objects to them, and you can get the name of the constant enum and the value, the underlying value of that enum. And ideally, you would reference that once you get to the technical area where you'd actually need the underlying value. In Python, that's implemented as a class. Other languages have it as an actual type beyond classes, but that's how you guys will probably be using them. Anyway, so what did we just talk about? Objects and immutable types was kind of our overview. All of the data structures, right? You have arrays, and then you have 3 things that extend from arrays: stack, the queue, and the multidimensional array. We have our unordered data structures, right? That's all reliant on the whole hashing protocol, and we have both sets and dictionaries that come out of that. And then in terms of object-oriented programming, we have classes, which have member functions, right? Functions that ride on the classes, instance variables, variables that define from the classes, equality, and hashing. And those are, you know, obviously all important when you're using them with things like sets and dictionaries. And then inheritance to let you define how classes extend from other classes. And then briefly touched on enums. Just have names and values. It hides complexity. It's a good thing to use in your code when you're trying to hide away some of this technical stuff. So. Okay, and I think I'll try to share this whole Python notebook with you. I've got some more examples in here of inheritance and some enumerations down here at the bottom. For example, I have this math class that defines 2 constants, pi and phi, and maybe you want to use them later. So, for example, when calculating the circumference of a circle, I just want to reference the math.pi.value. I don't want to have to type out all of those numbers, right? That's just one example use case. But does anybody have any questions about what we just covered? I'm seeing some stuff in the chat here. What about trees? Yeah, I didn't really show trees here. You can use them if you want. Different kinds of tree structures are you know, built on different types, but Python doesn't directly implement a tree. But since you do have references by values, what you could do is you could create a node class, right? Your node class would have 3 instance variables. One is the value, one is the left node, and one is the right node, right? And those would just be set equal to other nodes, and that's how you would build your tree. If the left and right are null, there's no extension to the tree. That's a really basic way that I would implement a tree. I mean, I can add an example of that for you guys too. I don't know why it's math.red and not color.red. It should be color.red. Thank you for pointing that out, Rachel. Yep. Red is my favorite math too. Yeah. Okay, cool. Does anyone have any other questions about what we covered?
So just a little bit of history for the young ones. Back in the 80s and even early 90s, object-oriented was still emerging. And prior to object-oriented, you didn't think about packaging an entity with its data and functions as an object. You thought about everything in a very linear and blocky fashion. So your data lived one place, your functions lived another place, and you kind of connected it all together with wire and duct tape, and it all just sort of worked. And it was, once you change your mindset to object oriented, it's almost hard to understand that. But obviously, object oriented is an intuitive and natural way for people to deal with code. And I'm glad it evolved.
Yeah. I see some people commenting on red black trees. I didn't include those, just like I didn't include trees. But red black trees, like Rob is saying, they're cool in theory, and they're kind of cool to learn about in theory. But I don't think you guys will be utilizing them in your mods. Maybe you can. If you figure out a cool, unique way that you're going to use red black trees and have a cool implementation of them, go for it. Be my guest. I'd love to see it. Okay. Yeah, I think that's it for this then, for these slides. Unless anybody has anything following up, and obviously you can you can message on Discord.
Just to expand a little bit on Sadiq's question, these things do map over to many other programming languages. So for those familiar with Java, arrays are array lists. You can build stacks and queues from them the same way. Dictionaries map over to hash maps, and sets map over to hash sets. So a lot of these things just have slightly different names, but they're the exactly same concept. And there's a little bit of discussion going on why you'd want to use an enum. The main reason why I use them in Python is mostly for type safety, so that I know for a fact that I'm selecting from only the options that I should select from. So you can say things like, if my color is color.red is safer in Python than saying if my color is string red, right? Because if I make a slight typo in that, if I'm just comparing the string values, you might get some errors that sneak in that are hard to catch. But when you use enums, you get very clear options, and you can't pick the wrong option. So the interpreter will actually help you catch some of those errors if you use an enum.
Right.
So it's really just a safety thing.
Using the color here constrains you to just the 1, 2, and 4. You can't use anything outside of that. And when you're writing your programs, you know that that function is going to be used with only that type, and it'll only be able to pass in those values.
And in a lot of programming languages, if you have a good development environment, it'll also give you like autocomplete that can make stuff easier, because the compiler or the tool knows what the possible options are, whereas it doesn't know the possible options for string. And it often is just more readable when you're explaining, when you're trying to read this as to understand the code and not just use it. You can see exactly what the set of color means, and you don't have to wonder what the possible values of color are.
Yep. All right. Cool. What do we have now?
I think it's Q&A. Let me double check.
Yeah, we have Q&A till 11:30.
Yes,
Okay.
we do.
Cool. So, sure. So questions about agile methods and this Python intro, feel free to ask.
The seminar today is at noon. It's from 12 to 1 p.m. Eastern time. It's with the head of the Computer Science and Artificial Intelligence Laboratory at MIT, CSAIL. I believe you heard from one of the instructors from CSAIL yesterday. This is the head of CSAIL.